let's go to page 144, and this section 11.8. This section is on area of a triangle. So you have a triangle ABC. Okay. Now, if only one side is known, normally they will give you the altitude. Okay. So if you know one side, if one side is given, then they will give you the altitude. So the area, they use a bracket for area. So area of the ABC is equal to 1/2 the base times height. Okay. So this b is not the little b over here. So if one side is given, then you have to know the altitude. So it would be 1/2 base times height. Okay. Now if two sides are given, if you know the two sides, okay, normally it would be like one of the angle would be like this, right? And this would be the side. Okay. So if two sides are given, then the ABC will equal to 1/2. Now in this case, you still have the base, okay, but this would be AB sine theta, okay. So A sine theta is like your height, okay, or B sine theta, depends on which way the angle is, okay. So anyway, the angle would be between the two sides, okay. So it depends on what side is giving and what angle is giving. So equal to 1/2 AC. Well, actually, I'm going to call this sine C. Okay. So yeah. So and then you're going to get if the angle B is given would be AC sine B and equal to 1/2 BC sine A. Okay. So it depends on what two sides are giving what angle. So but the angle is between the two sides. Okay. So because what happens so one of this combination is the height. So they're the same. Okay. So for example, like B sine C would be like the height, for example. Okay. So that's two sides are giving. Now if they give you three sides, so one side and the height, okay, and altitude. Okay, two sides and angle. Okay. And if they only give you three sides, then the triangle ABC equal to, you have to use something called the Hero's formula. So the area of the ABC would be equal to square root of S, S minus so it would be S minus A, S minus B, and S minus C. Okay? Okay, and S is a semi-perimeter, so S will equal to A plus B plus C over 2. Okay? But this actually is a simplified version of another formula. Okay, let's say if you have a circle and if you have a quadrilateral, so any quadrant inscribing a circle, okay, and let's going to call it like A, B, C, D. Okay. So the area of the I'm going to call let's call A, B, C, D. Okay, so the area of the quadrilateral A, B, C, D. Okay, this is actually square root of the S minus A, S minus B, S minus C, and S minus D. Okay. So when you have a quadrilateral four-sided inscribed in a circle, the area of the quadrilateral is that. Okay. And what happens is if you have a triangle, okay. If you have a triangle, let's say if you cut this over here, okay. When you have a triangle, the D becomes 0, okay. So when you have a triangle, basically, if you keep moving this point over to here, So now the D equal to 0, then all you have is ABC, okay? So again, if you move this over along the circle, you end up with ABC. So in this case, this formula still applies. The only difference is that the D equal to 0. So if D equal to 0, this is gone, and so this formula becomes this for the triangle. Okay, see that? Okay. So just so this are kind of good to know. Now there's another thing about the triangle. If it's inside, if you have a circle inside the triangle, okay. So this is a triangle inside a circle, okay. But now if we have another situation, if you have a circle inside a triangle. Okay, so let's say you have this situation. So you have the A, B, C. So this is on page 147. Okay. And then you draw the radius to each side. Okay, so this is the in center, and the label this is X, Y, Z. Okay. So in this case, the area of the triangle is equal to the radius times the semi-perimeter. Again, S is half of the perimeter. Okay. So it's going to be equal to A plus B plus C over 2. Okay. Now there's also a kind of relationship between the circle and the triangle. See what happens if you have the area of the circle over area of the perimeter of the circle. This will equal to area of the triangle over perimeter of the triangle. Okay, so they have the same ratio. So in this case, you can simplify. So area of the circle is pi r squared, and the perimeter of the circle is 2 pi r. And so you have the area of the triangle, which is this over here, over perimeter, which is A plus B plus C, right? Okay, now if you simplify, okay, so pi cancel out, r cancel out, so you have r over 2 equal to area, okay, of the triangle over A plus B plus C, okay, and that is this, right? Because if you were to multiply by 2, you got r equal to 2a triangle over A plus B plus C. And if you times it by 1/2 and 1/2, so you got r equal to area of the triangle over, right, this cancel out. But what is A plus B plus C over 2? That's this, right? That's the S, right? See that? So again, this is where it came from, right? So you can multiply by, so you can do that, or you can do to get that formula, RS equal to area of the triangle. Okay. Okay. So again, you can see there's another interesting relationship between all these things. Okay, so let's go and do some example. Let's go to example 11-22. It's giving an equilateral triangle with a side length of S. Okay, find the area of the triangle in terms of S. So area, okay, you can, again, when you have an equilateral triangle, you cut in half. So this would be S over 2, and this would be, so this is 60 degrees, and this would be 30 degrees. Okay. So this is the long leg, this is the short leg. So long leg would be square root of 3 times that, so it would be square root of 3 S over 2. Okay. And now to find the area is 1/2 base times height, or you can just rotate this over. If you rotate it over, you end up with a rectangle. Right? You rotate this over to here. So you end up with a square root of 3 S over 2, and you got S over 2. So area will be just multiplied together. So you're going to get square root of 3 over 4s squared. Okay? And that would be the formula. So area of the equilateral triangle equal to that. Now, a lot of times they use the letter K because A is usually used for angle A. So they use K or use a bracket. Okay? So just be familiar with different terminologies. Okay, let's go to example 1123. It says, what's the radius of a circle inside a triangle? So you have a triangle and the side are 8, 15, and 17. By the way, you should recognize that this is a right triangle. Okay, and so you're looking for the radius. Okay. Okay. So again, you can remember the RS equal to area of the triangle ABC, right? Okay. And so you're looking for radius, so R equal to, now the triangle, because the A 15, 17 is a right triangle, so this would be base, it would be the height. Okay, so area of the triangle would be 1/2 base times height. Okay, and so the S would be 1/2 the perimeter, so it would be 8 plus 15 plus 17 over 2. Okay, so R equal to 60 over, okay, so 24 would be 20, so R equal to 3. Okay, and that's it.